For each number in numbers.
Similac Gain School with added gangliosides supports faster brain connections for faster learning.
That client review was brutal.
We're gonna be underwater for weeks.
I'm already so pruny.
This is fixable. Just use Grammarly. We'll crush it.
I'm already crushed. I cannot be crushed any further. Spoke too soon.
Okay, first use Grammarly's AI to sound confident so the team doesn't think you're drowning. Now let's get to that proposal. Grammarly can look through the proposal to find what's missing.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem partition array according to given pivot. Oh boy, am I excited to solve this very interesting problem today. The idea is we are given an input array of numbers, and you know what, I'm just not even going to bother with this explanation. I'll just run through the examples. So we're given an input array of nums. In this example, it could look like this. We're also given a parameter, which is the pivot. In this case, the pivot is 10. So what we want to do is partition the array. So we want the array to look something like this, where we have all the pivot values, however many there are. In this case, it looks like there's 2 occurrences of the pivot value. I don't think that's guaranteed. There could have been maybe none of them, or there could have been one of them, or maybe more than 2. But either way, we want all of those right in the middle. Or let's put it in the more general way, we want the pivot like this. And then we want the elements that are less than the pivot to be on the left side. And we want the values that are greater than the pivot to be on the right side. So when they say we're partitioning the array, it is actually a pretty straightforward partition. What about the relative order of these elements and these elements? Do they need to be in sorted order? No, because if we were doing that, well, we would just be sorting the array. We wouldn't be calling this a partition. So then can these elements be in any order? What exactly do we want? Well, the best way to show you is just to kind of go through this example. So I'll try to color code it. So the pivots are here and here. And I'm just going to scan through this from left to right. 9, here are 3, this side. So the output is going to be 9, 5, and I think 3. And then we're going to have, these are the values greater in the same relative order that they appear in the input. And these are the elements less. So how do we code this up? I mean, one very trivial way would just be to scan through the input, separate the elements into 3 different arrays. I'm pretty sure you know what the 3 different arrays are. One array for the elements less than, one array for the elements greater, and one array for the elements that are equal to the pivot. And then at the end, we just combine the arrays together. Could do that with a loop, could do that with some built-in functions or some other ways. Python has a very easy way to do this. So that's pretty much what we're going to do. And the fact that we're using extra arrays means the space complexity is going to be linear as well as the time complexity. Let's code this up. So I'm going to have an array for the elements that are less. I'm going to have an array for the pivot elements. I'll call that P to not have like a name conflict with that. And then I'll have greater elements here. Then I just go through every number. I have a few if statements. Is it less than the pivot? If so, we do this. If it's greater than the pivot, then we add it to the greater array. Otherwise, it must be equal to the pivot, in which case we add it to the pivot array. At the end, we can combine the 2 arrays. Python makes it easy for us. So this kind of follows like the drawing that I kind of had earlier, less plus P plus the greater array. So this is basically concatenating those 3 arrays together, and then we're returning that. I'll give this a run. You can see it works. It's pretty efficient. There is a way for us to solve this problem without having extra memory. Well, we are going to need an array for the output. We actually can't do this in place. Your first thought might be like, can we do the partition in place? And it's not that we can't do a partition in place. It's that then we would not be able to preserve the relative order of elements. How do I know that? Because I have a pretty good understanding of DSA fundamentals. Let me show you what I mean. Quicksort, I have a lesson for it on LeetCode.io. Very fundamental algorithm. It involves partitioning in a very similar way that we are doing in today's problem. And one thing about quicksort is that it is not a stable sorting algorithm. And that basically means that we do not preserve the relative order of elements as, you know, the states. So yeah, I mean, I'm not saying you have to learn these fundamentals from LeetCode.io, but I think it's worth your time to have a very, very solid understanding of these fundamentals. I think LeetCode.io is a decent resource for that. And I mean, there's some other courses as well that I think will definitely be worth your time, especially if you like Python. Like all these Python tips and tricks can be learned in this Python for Coding Interviews course, has a lot of interactive lessons and whatnot. But now to kind of solve this problem without using any additional space, it's going to be similar to what we did here. I guess one way to do it would be 2 pointers. So what I'm going to do is, like, based on how many elements we we have in the input, I'm going to allocate an array like this one, like of the same size. So I have the space for all the elements. We could just fill it in with all zeros initially. And then I'm gonna have 2 pointers. I could call them I and J. And so what those 2 pointers are gonna do is it's gonna start here and here. I'm basically gonna iterate from left to right and right to left at the same time. You could consider this a single pass algorithm, but I mean, technically it's double passing. The fact that we combine it into a single loop doesn't really change the fact that we're iterating over the input twice. But anyways, what we're gonna do is from left to right, we're gonna fill in the values that are less than. So anytime I see a value from left to right that's less than, so 1, 2, 3, I'm gonna add those values here. Boom, boom, and boom. So in terms of this array, we're also gonna be keeping track of pointers. So I could call that, let's say I2. That tells me like the insertion point, and then eventually that pointer is gonna end up over here. And I'm gonna have maybe J2 as well, doing something similar. So anytime I see a number that is bigger than 10, so as I iterate my J pointer from right to left, I'm gonna see 14, and I'm gonna see 12, and I'm gonna add those like this, 14 and 12. So okay, so then my J2 pointer will stop here. And so however much space is left here, in this case there's gonna be 2 spaces, I'm then just gonna fill all of these in with the pivot element, which is 10. So 10 and 10. So nothing super fancy here. Knowing this, we can code this up with allocating only a single array. Okay, so I just initialized a few pointers. I and J are gonna be at the beginning and the end of the array, same with I2 and J2. These are gonna tell us like the insertion positions of the result array here that we've declared, and we've created it to be of the same size as the input array. That's what we are going to end up returning. And so then the first part can just be like this, while I is less than the input. Even though I have this as my condition,
What?
inside of the loop, we're actually going to be manipulating both I and J. We just know that we only have to check one of these conditions. We just have to make sure this is less than that, or we could make sure that J is greater than or equal
I think traditional ebooks provide a really poor reading experience, and I knew that with the right server and full control
to 0. As long as one of those pointers is in bounds, we are good because we then know that the other pointer must also be in bounds because they're iterating over the exact same array, just in reverse order. Anyways, you'll see what I mean here. We're going to check if the number at index I is less than the pivot, in which case then we will say in the result, not at index I, but at I2, we're going to set this number, and then we will increment I2. Otherwise, maybe the number is greater than the pivot, in which case then we will assign it to J2. This part, we're actually going to be using the J pointer for that. So let me check if the number at J starting from the right side, because the order that we process these elements and place them in the output is going to be important. So the number at J, if that's the case, then we do this, and then we can decrement our J2 pointer. Now, either way, regardless of which of these executes, maybe both will execute, maybe only one will, maybe neither. Either way, we are always going to be shifting our I and our J pointer. So we can do this, I and J. We could do this, count the pointers like this, I2 plus 1, J2 minus 1. So I do believe like this, I2 plus ways you could do that like this. While I2 is less than or equal to J2, we could do this, kind of like the 2-pointer approach. Take the number for I2's position and J2's position and assign it to the pivot element, then update both of the pointers like this, I2 plus 1, J2 and J2's position and assign it to the pivot element, then update both of the pointers like the 2-pointer approach. Take the number for I2's position and J2's position and assign it to the pivot element, then update both of the pointers like this, I2 plus 1, J2 minus 1. So I do believe that this will work. Let's give it a quick run.
pambata lang daw ang gatas? Pang feeling bata din. Dahil nagbabago na ang katawan, dapat na maggatas
kind of like the 2-pointer and assign it to the pivot element, then update both of the pointers like this, I2 plus 1, J2 minus 1. So I do believe believe that this will work. Let's give it a quick run. Yep, and as you can see here, it does work, and funny enough, even the memory efficiency is actually lower than the previous solution. I'm not entirely sure why that is. I can understand a little bit why the runtime would be lower. But anyways, if you found this helpful, check